All right, so the question we had there before break was as follows. Please work number 22 in the textbook. Even though we worked it last time, we still wanted to get that solidified, all right, in our mind. So that would be where we are going, all right. So here we go, number 22. Here's what we've got. We have ourselves a 500 gram piece of iron. Okay. Specific heat of iron is 0.473 joules per gram degree centigrade. We're going to have a final temperature of the iron, and we're going to have an initial temperature of the iron. That initial temperature was 212 degrees centigrade, and we are going to place that in 2 liters of water. So what's the mass of 2 liters? 2,000 grams, right? Okay. 2,000 grams of water. Specific heat of water is 4.184 joules per gram degree centigrade. We're going to have a final temperature of the water and an initial temperature of the water at 24 degrees centigrade. Okay, so what are we doing? Let's draw ourselves a picture. Okay, so here's what's happening. We have got ourselves a nice cool bath of water here. Okay, and here's all the dimensions of the water. It's 2,000 grams. It has this 4.184 specific heat, and it's sitting there with a temperature of 24, and it's happy. And then what we're going to do is we're going to take a scalding hot piece of iron, and we're going to dunk it into that water. Now, what's the dimensions and what's all the statistics of the iron that we know? Well, we know that it's exactly 500 grams. It has a specific heat capacity of 0.473, and it's sitting there cooking at 212 degrees centigrade. All right. Now, it wants to know here what will be the change in temperature of the water. All right. So common sense is going to tell you the water temperature will go from 24 to something that is higher than 24. And we want to look at that subtraction value. Okay. Now, here's what I know. Whenever you dump that in there and you swirl it, like yesterday in the lab, it'll reach a state of thermal equilibrium. And at thermal equilibrium, the final temperature of the iron will equal the final temperature of the water. Now, what does that mean? That means that both of these values are unknown, but they are the same unknown. And in science, it's very important. You have to justify. Okay, just because something's unknown does not necessarily mean it's the same thing as the other unknown. Here's what we got. We got ourselves 2 equations. The heat of iron equals the mass of iron, specific heat of iron, final temperature of iron. And that little dingly thing there is bothering me. Let me get rid of that. Minus the initial temperature of iron. Okay. And the heat of the water equals the mass of the water, specific heat of the water, final temperature of the water, minus the initial temperature of the water. Here's what we got going on. The heat that leaves the iron is exactly equal to the heat that comes into the water. Alrighty, so negative mass of the iron, specific heat of the iron, final temperature of the iron, minus initial temperature of the iron, equals mass of the water, specific heat of the water, final temperature of the water minus the initial temperature of the water. Okie dokie. Mass of the iron. All right, Bonnie, are we ready? Are you feeling good? All right. 0.473 x minus 212 equals 2,000, 4.184, x minus 24. Now, are we happy with plugging that in? All right. Well, negative 500 times 0.473. Okay. So this right here is going to be negative 236.5x plus 50,138. Okay, so let's take a look, see at what I did here algebraically. I have taken a negative 1 times 500 times 0.473. Multiplied all that. And I got negative 236.5. And then I distributed into that x, put the x there. And then I distributed here, which makes, of course, a negative times a negative is a positive, 50,138. Okay, now I'm going to do the same scenario over here. I'm going to take 2,000 times that and distribute into there. All right, so that's going to be 2,000 times 4.184, which is going to be 8368 x minus 200,832. All right. Now what do you want to do? How do you want to solve this? Okay. So you want to combine like terms. Which side do you want to do what to? X is on the left. Okay. Again, it doesn't matter here, so we're going to subtract negative 8368x here. Cancels out. Negative 8368x here. You see, it really doesn't matter as far as your algebra goes. Some people are trained to put the x's on the left-hand side. Other people are trained, don't let there be a negative number. So see here, it's going to the left, but it's negative. If it went to the right, everything would have been positive. Okay? Me, I don't care, right? I mean, it doesn't matter. Negative 8,368 minus 236.5 will be y. Negative 8604.5, negative 5138, negative 5138 to, wait a minute, negative 200,832 minus 5138, negative 250970. Divide both sides by negative 8604.5 to give me 29.2 degrees centigrade. All right. As I've said before, the x here doesn't matter. You have to know what x is. And x is the final temperature of the water. Well, again, that's not what we want, right? We want the change in temperature of the water, which is the final temperature of the water. Okay, I know what that is now. Minus the initial temperature of the water. So let's see here. 29.2 minus 24, 5.2. So that right there is your final answer. All right. Did that help with the negative signs and so forth? Yes. Yes. Okay.
Can we do 33?
Sure. 33. Are we cool to move along? 33 sounds good? Okay. Well, 33 it is. A 500-gram piece of iron is heated in a flame. All right, so the mass of the iron is 500 grams. It's heated into a flame and dropped into the mass of the water is 400 grams at 10 degrees centigrade. So the initial temperature of the water is 10 degrees centigrade, right? Specific heat of water is 4.184. The temperature of the water rises to 90 degrees centigrade.